This problem is actually related with the Compton effect, and we are given that the wavelength of the scattered photon, it is twice the wavelength of the incident photon, which is given to be lambda, and the angle of scattering is given to be 60 degree, and we have to find the angle of recoil of the electron. Let us now find this. So in the Compton effect, the relation between wavelength of the scattered photon and wavelength of the incident photon is given by this expression. Here angle theta is angle of scattering. This quantity lambda c, which is h upon m naught c, is also called Compton wavelength. Now we are given that lambda dash is twice of lambda and theta is 60 degree. Let us now insert these two values in the Compton equation. And when we insert these values here, this becomes 2 lambda minus lambda, which is equal to lambda, and cos 60 is nothing but it is half, which gives me lambda is equal to h upon 2 m naught c. And we will be using this expression for lambda for finding the angle of recoil of the electron. So if phi is the angle of recoil of the electron, then it is related with angle of scattering by the following relation. Tan phi is equal to cot theta by 2 over 1 plus alpha, where alpha is the ratio of incident photon energy to the rest mass energy of electron, and we know that nu is equal to c by lambda for photon. Therefore this expression becomes h upon m naught c lambda. So if we put the value of theta equal to be 60 degree and the value of alpha, which is h upon m naught c lambda, and after that we know from the previous slides that you can see here lambda is equal to h upon 2 m naught c. We will be inserting this equation, and when we insert lambda equal to h upon 2 m naught c here, then this becomes cot 30 upon 1 plus h upon m naught c into 2 m naught c by h, which eventually becomes 1 plus 2, and cot 30 is nothing but it is root 3, which gives us angle of recoil of the electron to be 30 degree. So in this blank we have to fill actually 30 degree, which is the correct answer.